Ladies and gentlemen, welcome to section 12.6, Permutations and Combinations. We're going to start off with our very first vocab word. As many of you are probably wondering, what is a permutation? It is an arrangement of objects in which order, yes, it is underlined and bolded in blue for a reason, which order is important. So order is important when we're talking about permutations. Well, what does that have to do with anything? How many ways can you arrange the letters A, B, C? Well, let's go through this. Starting with the letter A. We have A, and then we go B, C. We can also go A, C, B. And then we go to our B's. B, A, C, B, C, A. And then finally with C first, we have C, A, B. And then we have C, B, A. So we can arrange these three letters in 1, 2, 3, 4, 5, 6 ways. But what if we throw in letter D or letter E? That would get really big, really fast. So what do we have to help us out with that? That is a factorial. So if we go back at this again, and a factorial is this little exclamation mark, right? 4 times 3 times 2 times 1. Well, there's 1, 2, 3. And if we go 3 times 2 times 1, that would be 6. Answer is the same as here. Maybe that would be a little bit quicker than writing out all your options. Let's move on to the next question, where we have Lloyd and 5 friends want to go to a movie. How many different ways can they sit together in a row of 6 empty seats? Well, how many friends can sit here? Lloyd and 5 friends can sit here, and let's say Lloyd sits there. Well, now, how many friends can sit here? Well, let's say I do. Ryan sits there, and 5 different friends can sit there, but Ryan sits there. So now we have Lloyd and Ryan are taking up the first 2 seats. How many are left for the next one? 4. Let's say Tyler sits there. Next one, 3, 2, and 1. You would multiply all those guys up, all your options, to get 720. And that's how factorials work. Let's get into some more permutations. And this is the definition of a permutation. Now don't let this scare you, because you have a button for this in your calculator. A permutation in a TI, and the ones that I have in the back of the classroom, you have to hit the P, R, B button on the top of your calculator, and then it's the button that looks like N, P, R. Now I'm going to write these 2 problems like this, but on your assessment you don't have to write them out like this. You can just use the button, but I'm going to show you how to use them. So for number 1, we have a word processing program requires a user to enter a 5-digit registration code made up of 7 digits. No digit can be used more than once. How many different registration codes are possible? Well, we have order is important, so yes, order is important in word processing codes. So we have 7 digits to use. That means we have 1, 2, 3, 4, 5 spots that are available. We could put 7 here. Then we could put 6 numbers here, 5 numbers here, 4 numbers, and 3 numbers. Notice how we do not use the 2 and the 1. So we only need to take these times each other, and that's why this formula is so important. And I'm going to write it out like this. We go 7 factorial over, and then we're choosing 5 of those, so we have 7 minus 5, close it up, factorial. We would simplify that to be 7 factorial over 2 factorial, which gives us 42. Now let's say you're using your calculator to punch that in. Well, I would hit 7 first, because it's the big number, the number that you're choosing from. Then you would hit PRB button on your calculator, and then NPR button, and it would show up something like this, and then you would hit the amount you're selecting from those 7. So I would hit 5, enter after that, and guess what? You're going to get 42, which matches this answer up here. Then next, we have James wants to place 5 of his 8 trophies on the fireplace. How many ways can he arrange the trophies? Well, let's say you have an A and a B trophy. Is this arrangement different than B and A? Yes, it is. So anytime you see arrange or arrangement, this probably means a permutation. All right, so always be heads up with that. If we would use this formula, how do we use it? We would go 8 factorial over, in parentheses, your number that you're choosing from, 8 minus the r is the number that you pick, so it's 5 factorial, which simplifies into 8 factorial over 3 factorial, which is 336. Now if you're using the calculator, again, you can ask me how you would use it in the calculator, but you would hit the PRB button, which stands for probability. Then you, then you would actually hit 8 first before you hit the PRB button, but you hit 8, PRB, and then you hit NPR, or select that from the menu, then hit 3, and you hit enter from your calculator, and that's going to give you 336 again. Now, how many ways can we put the letters A, B, C, D down in groups of, here's the important part, in groups of 3? Well, let's check it out. I'm going to start with A first. I can go A, B, C. I can go A, C, D. I'm done with A's. Moving on. B, A, C. B, C, D. C, A, D. C, B, D. D, A, B. Dab. D, B, C. Now, I put those all in the groups of 3, but now, as you notice, we have overlapping ones. That BAC is the same as ABC. Groups, the order does not matter. Also, we have CAD already over here. We have CBD in another order here, and then also we can cancel out this one. So we can only go here, 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 and here. So that is putting these 4 letters into groups of 3. We can only do that 4 times. Now what is this? This is a combination right here. Combination is an arrangement or listing in which order is not important. Again, it is bolded and underlined in blue. So not important is probably very important to put down. See what I did there? Now, this is the formula that we would be using for a combination. We have n factorial over n minus r factorial, r factorial. We are dividing out, we are taking out all of these guys with this r factorial. We are dividing out those guys so we don't use them again. So what do these problems look like? 3. We have a group of 4 students is selecting corsages, boutonnieres, I can't say that word, to wear to the spring dance, or maybe it's prom. They can choose from 4 roses, 6 carnations, and 8 tulips. If all of the flowers are different, how many ways can 4 flowers be chosen? So first we have to figure out the total. Our total is all the flowers added up. So we have 4 roses plus 6 carnations plus 8 tulips. That gives us 18 flowers to pick from. So we want a group of 4. So is this a combination or a permutation? We have a group. Anytime you have groups, order does not matter. Order is not important. Order not important. So we have, if I can spell this out all the way, we have a combination on our hands. So how do we write this out? Using the formula, we would go 18 factorial over 18 minus 4 factorial 4. Factorial would give us an answer of 3,060 ways 4 flowers can be chosen. But now we don't want to write it out like that, so let's say we want to use our calculator. So in our calculator we hit 18 first, then the PRB button, then we would select the NCR choice, and then we would hit 4, and then you'd hit equals, and that should give you 3,060. And now again, if you can't find the buttons that I'm talking about, just ask me in class and I'll kindly point you in the right direction. Now with 4, we have a group of 4 seniors, 5 juniors, 7 sophomores have volunteered to be on a fundraising committee. Mr. Davidson needs to choose 12 students out of the group. How many ways can the 12 students be chosen? Well, how many total do we have? Again, we have to find the total. Just going 12 and picking here doesn't help us. So the total is 4 plus 5 plus 7, which is 16. And we are choosing 12. So using our formula, we would have 16 factorial over 16 minus 12 factorial, and then still over 12 factorial, gives us 1820. Or using calculator, hit 16, then your PRB button, you select NCR, and then hit 12, and that again is going to give you 1820. Moving on, let's get some help identifying permutations or combinations. During a fire drill, a teacher checks the students in a row to see if everyone is present. And when a fire drill, does it really matter if they are sitting in the correct order? No, it does not. Order does not matter, so it is a combination. Then, in preparing for a competition, a tennis coach lists his players in order of ability. Well, if Mr. Litke is the best tennis player, he should be listed 1 and not 2nd because order is important. Order, it even says in the problem, order, so this is a permutation. 7. A teacher uses a random number generator to create a seating chart for 20 students. Well, if I am sitting at the desk right now and you're sitting in a spot, is it different if you sit in my desk and I sit in your spot? Is that a different seating chart? Yes, it is, so therefore, order matters. And then finally, 10 athletes enter a race. The top 3 finishers move on to the next round. Now, the important part here says the top 3 finishers. It does not say first, second, and third. It just says top 3 finishers move on to the next round. It doesn't matter if I'm first or second because I still move on to the next round. So here is a combination. And finally, we have 16 people have signed up for a table tennis tournament. If players are put into groups of 4 and the draw is determined randomly, what is the probability that Heather, Aaron, Michelle, and Patrick are put in the same group? Well, first we have to decide, is this a combination or a permutation? We are looking at group, so it is a combination. The total people in the class is 16. So since it's a combination with 16 people, we are going to write this as 16, then PRB, and it's an NCR. You hit 4 because we're groups of 4. That's going to equal 1,820. However, we are looking for the probability. What is the probability, right? So the probability is not 1,820. It is how many out of 1,820. Well, there is only one way that you can select that group, and then one way out of 1,820 different ways. So your probability would be right here. And that does it for the last question. And finally, we are done with section 12.6, permutation and combinations. Good day.